Okay, this is our presentation for the senior project. This is the GuardianPi. We are group Aperture Shadows. The group consists of myself, Steve, Forrest, George, James, Cameron, Andrew Vall, who is not present, and Wahida. So the introduction, what is the GuardianPi? Is an affordable AI-powered home and business security system. It uses the Raspberry Pi, OpenCV, DeepFace, and PIR motion sensors to provide real-time facial recognition and intrusion alerts. Why GuardianPi? It's a high-cost security system that is accessible to many users. Traditional security lacks smart authentication features, and our system is designed for affordability and accessibility. The system architecture, our hardware components consist of the Raspberry Pi V4, the camera module for capturing facial images, the PIR motion sensor for detecting motion, and the Sense Hat for collecting environmental data. Our software and frameworks include OpenCV and DeepFace for facial recognition, Flask, MySQL, and AWS recognition for data storage, multi-factor authentication for OTP, email, and voice recognition. We are using PushSafer for the real-time notification system. The facial recognition and authentication goes as follows. The core features of our AI-powered facial recognition is using the Raspberry Pi camera, OpenCV, and DeepFace for live image capture and analysis. This verifies authorized users by comparing live images with the secure database profiles. It enhances security with multi-factor authentication. Our primary facial recognition is supplemented by one-time passwords via the phone or email alerts with video capture for unauthorized access attempts, optional voice recognition for added verification, and proactive intruder alert system, which will trigger an alert upon detection of an unauthorized face and activates an intrusion alarm with potential warning messages or deterrence. Our web dashboard. This is a comprehensive web dashboard. It displays environmental data like temperature, humidity, pressure from the Raspberry Pi SenseHat itself. It visualizes system health and room conditions in real time. It shows user authentication status via the SenseHat's LED matrix provided by green or red colors and allows privileged users to monitor real-time alerts, intrusion logs, and facial recognition images. Key security features accessible through the web dashboard include multi-factor authentication status, intrusion alarm activity, and real-time alert logs.
Okay, so the GuardianPi utilizes the Raspberry Pi SenseHat sensors to continuously monitor environmental conditions in the room and the hardware of the Raspberry Pi. The SenseHat includes a variety of sensors, such as the temperature, humidity, and pressure. These sensors provide valuable data that helps track the health of the system and its surroundings. The temperature readings ensure that the Raspberry Pi is operating within safe environmental limits, preventing overheating and hardware damage. While the humidity and pressure readings ensure the environment of the room are within necessary ranges. Additionally, the SenseHat's LED matrix is used to visually indicate users' authentication status. The LED matrix displays a green light signaling access is granted and a red light when access is denied. The collected data is then stored in a database and visualized on our web dashboard. This allows authorized users to use and monitor both the security system's performance and the room's condition in real time. This integration of environmental data helps improve the overall reliability and effectiveness of the GuardianPi system. To enhance real-time security monitoring, GuardianPi integrates PushSafer as a real-time notification system to alert authorized users of detected motion events. Push Safer provides a reliable notification system, ensuring immediate delivery of critical alerts to designated devices, enhancing response time efficiency. These notifications are sent to devices within the authorized users group in the Push Safer web portal, where users register their device through a provided QR code. When movement is detected, the PR through the PIR sensor, the system triggers a notification request through the Push Safer API, delivering critical security alerts with details such as the timestamp and priority of the notification. Using Push Saver provides a reliable, efficient, and low-cost method for delivering security alerts directly to mobile devices. This ensures continuous surveillance even when users are away. And as you can see, there are some screenshots of what the user will receive on their phone, as well as the code for the notification configuration.
Team responsibilities. So for myself, Andrew Palela, I'm the team lead. Went over project management, timeline oversight, quality control, and then I also performed the hardware setup and initial software installation.
My name is Steven Vartanian. I was in charge of the SenseHat sensor data logging, the motion detection scripting, and the push notifications for motion events.
For web development and database management, I, Faris, and Hida and Cameron, we designed and developed a user-friendly dashboard and implemented a secure data storage for authentication logs.
James and George Elias, in charge of AI and facial recognition. We're in charge of implementing and optimizing the facial recognition algorithms. We used OpenCV. We also had to figure out how to enhance the AI performance inside the environments that we're working in, such as lighting and such, and implementing the Pi camera they used.
And then Andrew Vall is not present at the moment for this recording. He is currently at the hospital for his father. So he maintained the project documentation and prepared the final presentation and demo materials. So the contribution for myself as team lead for our project, my primary responsibilities encompass project management, technical setup, and collaborative integration efforts. I communicated and checked in with all sub-teams and focused on ensuring the project remained on schedule, adhere to quality standards, offered help, and facilitated effective team communication. I scheduled and organized regular team meetings to discuss progress, address challenges, and coordinate tasks. Team meetings were held every Monday and occasionally on weekends. We worked on weekly goals, discussed problems, solutions, progress, and how to implement our technologies for our project. I served as the primary point of contact for team communication, ensuring information was dispersed effectively. I configured and set up the Raspberry Pi hardware, ensuring proper functionality. I installed all necessary operating system components, software dependencies, and established a stable development environment. I ensured all software and hardware was tested for basic functionality. Additionally, I collaborated closely with Steve V to integrate the Pi motion sensor, the SenseHat, and push notification functionalities. I participated in the design and implementation of the integration process, ensuring functionality between the hardware and software components. I also worked with Steve V to troubleshoot and resolve integration issues, ensuring reliable performance. Overall, thus far, my contributions have been critical in establishing a solid foundation for our project and getting us to where we are at while being a positive team player. And I'm confident that the team's collaborative efforts will lead to a successful project outcome.
As a front end and back end developer for the GuardianPi project, the software developer team and I took charge of implementing the HTML and CSS for the website, designing the layout and user interface to ensure a clean and functional experience. I contributed to the project design and management, helping to plan out the structure of the system, organize the development tasks, etc. I also worked on creating the initial templates and setting up a foundation for the website. My role was also involved on the future planning of the database integration, where we're going to design all the data from the Raspberry Pi, including facial detection and motion sensor inputs would be stored and retrieved efficiently. I played a part in designing the notification center and ensuring that the security alerts would be displayed in real time for the users monitoring their system. I also worked on implementing user accounts, allowing different access levels and personalization based on security preferences. Moving forward, I will continue refining the database connections, improving the UI for better usability, and ensuring the data flows smoothly between the Raspberry Pi, the backend, and the front end, making GuardianPi a reliable and responsive security monitoring platform.
As a developer of backend security, I've been working on implementing a secure password hashing and verification system to utilize our website with. This system is known as Argon 2 in Python. The goal is to ensure users' passwords are stored safely by hashing them with a strong memory-intensive algorithm while also incorporating salts that add an extra layer of protection. Additionally, the system includes a verification function that checks whether an entered password matches the stored hash, ensuring only authorized users access or gain access. By using Argon 2's built-in security features, including adjustable time, memory, and parallelism settings, the implementation enhances password protection against brute force attacks. In the future, I plan to refine the code by improving our user experience and integrating a database storage for better scalability.
I was responsible for capturing the Raspberry Pi SenseHat sensor data and implementing the PIR sensor. Initially, I planned on incorporating the software Push Bullet to send push notifications to mobile devices. However, after researching and testing the Push Bullet API, I discovered that this software only works with Android devices and is considered untrustworthy by Apple and Microsoft. This led me to discover the software Push Safer, which not only works with Apple devices, but is trusted by both Apple and Microsoft. After setting up my Push Safer account, I was able to create an authorized users group within the Push Safer web portal, where users join via a provided QR code. Once the users are registered to the group, they will receive instant push notifications to their mobile device when motion is detected by the PIR sensor. When this happens, the notification configuration from my Python file is sent through the PushSafer API with my private key. I believe using PushSafer provides a reliable, efficient, and low-cost method for delivering security alerts directly to mobile devices, ensuring continuous surveillance even when users are away. I also coded the Raspberry Pi SenseHat to capture a variety of data, such as the temperature, humidity, and pressure. This data is then written into a CSV file that will be used to import the data into our database. I then wrote a section to illuminate the LED matrix green for access is granted and red for access is denied. This integration of environmental data helps improve the overall reliability and effectiveness of the GuardianPi system.
As a front-end and back-end developer for the GuardianPi project, the software development team and I worked collaboratively to implement the HTML and CSS for the website. I played a key role in designing the website prototype on Figma, where I focused on structuring and aesthetically designing the layout to ensure the site is both visually appealing and user-friendly. By carefully considering the user journey, I strive to create an intuitive interface that enhances overall user experience. I was also responsible for implementing the base code for several pages, including building the text input fields for the login page, ensuring functionality and smooth user interactions. In addition to this, I actively contributed to the development of the backend, which will involve integrating the website with the Raspberry Pi. In the future, I will be implementing the database connection between the website and the Raspberry Pi, which will play a vital role in storing and managing data. Moreover, I will also continue working on improving the user interface, focusing on making the website even more intuitive and responsive across different devices. A key part of my responsibilities will also involve ensuring that sensitive user data, such as passwords, is securely stored within our database using proper encryption techniques. This will include managing other relevant user information, enhancing security measures, and optimizing the overall performance of the website and database interaction.
So I'll just speak on behalf of Andrew Vall. As the designated team member, he was responsible for documentation and presentation. He played a key role in ensuring the clarity, organization, and professionalism of our project's deliverables. For the midterm presentation, he developed the PowerPoint slides, ensuring that they adhere to the required formatting guidelines while maintaining a logical flow that effectively conveyed our project's objectives, methodology, and progress. To facilitate collaboration, he structured the presentation file in a way that allowed our teammates to incorporate their contributions. Additionally, he created and formatted the project report, outlining the key discussion points and organizing its structure to align with the group's responsibilities. This approach allowed each team member to effectively integrate their respective sections, helping with the documentation process and ensuring consistency across our deliverables. His role in documentation and presentation not only supported the technical aspects of our project, but also ensured that our work was communicated effectively and met academic and professional standards.
Right, for our contributions as the team members responsible for implementing and optimizing facial recognition, we focused on enhancing AI performance in constrained environments, that being lighting, spacing, etc. Using OpenCV, which is an open source computer vision library that provides real-time computer vision and image processing, including facial detection, object tracking, and machine learning applications. We developed and fine-tuned our model to accurately detect and differentiate between trained and unknown users. To achieve this, we helped curate and pre-process the diverse dataset, was the multiple trained users, ensuring a robust training with real-world variations such as lighting, angles, and expressions. This is George, who also worked with James on this part of the project. We also optimized the model execution by refining the given parameters and streamlining the model to balance accuracy and efficiency. So when pictures are uploaded to the model, they have to be trained against the model so that they can be detected. Additionally, we integrated adaptive learning techniques to improve recognition over time, such as like adding more pictures makes the model more accurate. And to enable real-time facial recognition, we integrated the Pi camera with our system, ensuring seamless image capture and processing. Our contributions ensured that our facial recognition system was both precise and performant, playing a key role in the success of our project.
This is the Argon2 hash function. It starts with creating the class, which initializes variables like number of iterations, the memory usage of each hash, number of parallel threads, length of the hash in bytes, and length of the salt in bytes. And then below it is a function that hashes the password, where it hashes the password based on password hashing function or object, splits the salt value to isolate it, prints the username, prints the hash with the salt value in it, prints just the salt value, and then returns the three values of username, hash, and salt value. This is the other function, password verify. It verifies the password and authenticates the password and username against the hash. Then there's another function where it stores the password so far in a text file, but we are planning to put it in a database, probably MySQL. This is what it prints out. So it still needs to be fully implemented when creating an account. So when you enter a password, it needs user input to resubmit their password. Then it verifies the password, and then it stores the hash and salt inside or lets you know that it stores the hash and salt inside the text file. This is what it prints out. The top is a successful one, enters my first name and then my password. And then if it asks for the password, I type it in again, and then it'll say password is valid, and then it'll store the hash and salt, as you see in the bottom picture, where the P equals is the hash, and then the comma after it is the salt. The salt is just an extra layer of protection. Just say like if two people have the same password, those people, say if like, you get hacked or something, only one of them will maybe get, yeah, so. And then this is running the Argon hash function. when it's not valid. So if you just type in your verification as Doe, the password's not valid, it will fail and it won't store in the hash function.
To begin, this is the base layout of our website that we currently have. This image displays the login page where the user will have to log into the website in order to access all the features that are available with our facial recognition. Also on this layout, it shows the sidebar where users are able to access the data, notification, security, account settings, about us tabs as well. For the data table, this page displays a data table where we will be logging user actions, timestamps, and other logs that will be stored within this data table for the user to have access to.
Here is the GuardianPi notification page. This is going to act as a bridge between the GuardianPi system and the user, ensuring that important security events are immediately communicated. Whenever a facial recognition scan occurs or a unauthorized access attempt is detected, motion sensors picking up on activity, the GuardianPi is going to send an instant alert to the website. And these notifications appear on the website, keeping the users informed of all security events as they happen. This enhances the security by providing real-time updates, allowing users to take immediate action when necessary, whether it's a successful login, a denied access attempt, etc. Here as well as the security logs. This is a crucial part of the GuardianPi's website. Every action performed by a user on the website is going to be tracked and recorded in a structured log. This ensures like transparency, accountability, and adds an additional layer of security for all the users. Whether it's like a simple login attempt or a major account change, our system is going to keep a detailed record of who did what and when. Every time a user logs into GuardianPi, a timestamped entry is recorded in the security log. This includes a username, the login time, and the action that's being performed to help the administrators monitor activity and detect any unauthorized access attempts. If an unknown or suspicious login occurs, the system can flag it for review and notify the appropriate personnel.
The user settings is where the user will be able to view their information, such as their first name, last name, email, and phone number. And they also get to have an avatar for their profile, and users are able to edit this information whenever they'd like.
So here's the About Us page. It's just a simple, brief explanation on what GuardianPi is for these users. Um, yeah, it's just a short summary of GuardianPi and what our intentions are for this system.
So here we shift over to the facial recognition portion of the project. So the first component of the facial recognition um, scripts is the image capture.py. This is what allows us to take pictures with the Pi camera that's integrated on our Raspberry Pi. And you can take um, as many photos as you want, but we're trying to stick to at least like 12 maximum just to ensure like storage and like better efficiency for the project and accuracy. So like in the picture given, it shows my face, for example, being taken on the images. What it does is you hit spacebar and you can take as many images as you want, and it creates a data set with your pictures in it. So in that code, you just change the name where it says Forest right there in the person name section, and that would create a data set for Forest, for example. In the next code, we have model training.py. This is actually the part of the Python script which learns the face in the data set. So it takes everything in the dataset folder that's automatically generated by the image capturing, and it trains it against this model. So it actually learns the faces, and this is the AI portion that is integrated with facial recognition, and it also works like with deep face, but we used facial recognition. And this is where it learns all the images. So here in the example, you can see it processing each image individually. After it's done processing, it creates a encodings.pickle folder. That pickle folder is what allows the actual facial recognition software to recognize each name on each user. So now we run the actual facial recognition part of the code. This is what this is the part that actually recognizes each face. So for example, my face was the only part of the data set that was included at the time. So it recognizes my face on the left as George, and any other face that is not in the data set that is not recognized will show as unknown. This is the part of the project where we want to integrate things like the color on the Raspberry Pi. So in the actual image, it shows green on the Sense hat, and yeah.
So here's our current Raspberry Pi setup with the Sense hat working, the motion sensor connected with the wires, and then we have the camera as well. Our current status, so we've successfully implemented a facial recognition with an accuracy rate could be readjusted. Successfully integrated the Pi camera, integrated MFA and push notifications for motion detection. We developed a basic web dashboard for monitoring alerts, an integrated motion sensor detection and Sense hat sensor data logging. Our next steps include optimizing the AI model for faster and more reliable recognition, expanding MFA options, potentially adding fingerprint authentication, implementing the database for the facial recognition, enhanced real-time notifications via mobile map app integration, and the Argon 2 hash function website implementation and enhancements. And here are our references. And thank you for listening.